Hi, our research is projecting urban heat island exposure in Texas using socio-demographic factors by Grace Zhang and Mannat Olawale.
So here's our abstract describing our research.
To introduce our topic, the urban heat island effect is a phenomenon where temperatures increase due to city infrastructure re-emitting the sun's heat. The objective of this project is to determine whether there is a spatial relationship or possible correlation between demographic factors, specifically income and minority groups present, and the urban heat islands. This will enable scientists to target specific counties that we looked into within the Austin and Houston cities to facilitate the development of more equitable environmental policies. So the two research questions that we looked into are certain demographic groups in Texas disproportionately affected by urban heat islands? And also, what is the spatial relationship between demographic factors and the urban heat island effect in Austin and Houston?
So our study area within Texas consisted of Houston and Austin because these areas have historically been affected by redlining and also the current present day residential segregation that occurs in these areas.
So for our research, all the data we used was secondary data. For surface data used in our model, we used the Google Global Surf Urban Heat Island Explorer app. And from there, we extracted data from 38 urban clusters across Texas. For the demographic used in our model, we used the US Census and extracted the data by county. And constructing our maps in ArcGIS, we used two datasets, a census dataset and an urban heat island dataset.
Our data processing techniques began with a spatial component, which essentially used ArcGIS to merge datasets containing the urban heat island effect, as well as different demographic factors. And we used this to create a bivariate choropleth map that analyzes spatial correlations. Our second component, which was the computational part, was first using Excel to calculate the Spearman correlation coefficient analysis with the urban heat island effect versus each demographic factor. From this data, we constructed a random forest model, which is a type of machine learning model that uses ensemble architecture, and it uses multiple different algorithms in order to train and test a dataset. We also repeated testing our model 3 trials in order to determine how accurate it was.
So this is the first map made on ArcGIS, comparing the median household income to temperature. So looking at the legend, the two most significant features to focus on are the bright blue, which signifies areas with the highest temperature and the lowest income, and the dark brown, which is areas with the highest temperature and highest income. The center brown color indicates there's a possibility of little to no correlation. So looking at the Austin map, there is a high presence of the center brown color in the legend, meaning that there's less of a correlation between income and surface temperature. However, in Houston, it is visible that there is a greater correlation. Towards the bottom left of the colored area, it shows that there is high temperature and low income relationship in the southwest part of Harris County and the northern part of Fort Bend County. Next, looking at the percent of minority maps, we're looking for areas where there was high surface temperatures and high percentage of minorities present. So in this case, this is where the dark brown and dark orange tones are present on the map. Again, in Austin, there's less correlation. However, there's some present in central Travis County. In Houston, there is some brown tones present or outside of central Houston and mainly southwest again of Harris County.
So our predictive modeling used a random forest model, and we trained and tested the dataset using the SUHI intensity from a Yale dataset that consisted of pixel level composites of daytime annual urban heat island effects calculated through this equation. And our model itself involved different decision trees as shown in this image, and we used 100 decision trees to train our dataset of 38 counties across Texas. So here is a sample of our code. We also calculated Spearman rank correlation analyses to determine the R values that would show the correlation. So -1 would show a strong negative correlation and 1 would show a strong positive correlation. And the only R value that was significant was between daytime urban heat island effect and percent black, with an R value of 0.337, and the p-value was less than 0.05. The random forest feature importance also confirmed this, with the greatest feature importance being the percent black versus percent white and median household income. We also trained and tested the model to determine accuracy with an 82% mean accuracy and 84% on the highest performing trial. However, one limitation is that our small sample size of only 38 different counties could have skewed the accuracy in some way. So in conclusion, we have determined a significant correlation between urban heat island effects and the percent of Black people residing within one county, which could be an effect of redlining within the 1950s, and this could cause segregated neighborhoods that have less capital and less resources to construct areas that have less impervious surfaces. And the results indicated no significant correlation with the median income or percent of white data sets. However, in our spatial analysis for Austin and Houston, we determined there could be a possible relationship between urban heat island effect and demographic factors in Travis and Harris County, and we also predicted the urban heat island effect with demographic data with an accuracy of up to 84%.
Some of the best features of this research was we were able to experiment with machine learning models and using new programs and softwares, also learning how to collect real-world globe data. Some challenges we faced is we originally tried to create our maps on Google Earth Engine, but we had trouble merging our data sets. We also had to complete this in a short amount of time, and there was a learning curve for ArcGIS and Google Earth Engine.
So from this internship, I've gained a lot of experience with research and conducting my own projects, and I've also realized and fine-tuned my future career path that I'd like to go into, which is data science.
This internship has given me the experience to conduct real-world research and learn about the opportunity available through remote sensing and data analyzing.
So thank you to our mentors, Femi, Tanzia, Dr. C, and Dr. Yitong for their support throughout this internship. And we'd also like to thank the NASA SEAS internship itself for providing us with these opportunities.
We have learned a lot of valuable information about data analysis and the urban heat island effect. Thank you.